There are tons of different videos about aluminum wheel crack repairs, and I just decided to make another one. Not because this is the only way to skin the cut, or this is the best, I want to show you the best way to do it. I'm just gonna share with you the way that works for me. So the patient on the table is the BMW wheel, and it's about 20 inches or so, and basically speaking, over the years I've done like a lot of them, and I work on a metal bench, so if I do aluminum wheel, it's always a good idea to put a couple of rugs underneath it, just to make sure you're not gonna scratch that wheel to death. And if you put that wheel pretty much closer to the corner, that means you can get almost all the way around. It is entirely up to you, but I personally do not take any wheels that have any chunks missing, or if it has cracks on the sprockets or front part of the wheel. The wheels are very poorly designed. The whole load is based on the front part. If you have sprockets in the middle, it will work a lot better. As you can see, this is the old seam that somebody else welded. I know it wasn't me, because the bead is very narrow. You can just see my finger, and my finger is pretty much wider than the bead. All it means that people just welded over a crack, and you're probably going to be very lucky if they manage to grind in a little bit. But because aluminum has a very high thermal conductivity, it's very difficult to penetrate unless you actually cut everything out. So what I'm going to do, I'm going to put a very thin 1mm blade through the crack. The idea behind this process is I just want to have really clear indication, good visible mark where this crack will end. Some people choose to drill the ends of a crack with a little drill and so on, just to supposedly stop the crack spreading. That actually very much pointless exercise, simply because you will still need to re-weld everything up. And in my case, when I'm going to be welding, I'm going to be welding really hot. So if there is any cracks, because aluminum will heat up and expand, I will see them right away. And if I would drill them out anyway, I will need to fill it up later on, so it defeats the purpose. But you just need to pay attention and run it really hot. In my case, I just want to have this crack completely visible, so I have really good indication of my working area. What you'll see me using quite a lot is 1mm disc for purposes that not really designed. This disc wasn't designed to use. Like you see me cleaning up, I really like that very thin edge, which I can use to get into different locations. And because I'm not really applying any load, and I always wear full face screen and goggles underneath it if I have to, but this one is actually air-fed screen, so nothing gets in and around, and I'm comfortable with what I've been doing it so far, and it works really well for me. You may have different techniques or a method, but this way I can get into every little corner, and I can be very precise with that blade. So once the area is cleaned up, what you will see is I'll put a welding bead, just bridge it over and put a welding bead over top of that. Well, unfortunately I forgot to press a record button, and that's probably going to be one of the main reasons why I don't work for Warner Brothers Studio as a cameraman. So nothing fancy about it, just deposit quite a lot of material and build the bridge over top of that crack. As you can see, I don't really care how it's gonna look, I just need to have clean metal behind that crack. Now I'm gonna clean up the front side of this weld, and just clean up area, so when I'm gonna be welding, the area will be relatively clean. You will never get rid of it, because aluminum is extremely active metal, and it will oxidize really rapid. And what you see, it looks like a different color just now, but it's actually light shining on the scratches that left by the disc, and it looks like it's slightly different. It's very difficult to film on aluminum because the shiny surface, you kind of losing the depth perception on it, and it's really hard to say. So all of that area needs to be cleaned up. Once the area being cleaned up, and I can see my crack really well just now, I know exactly where I'm working. So what I'm going to do, I'm going to cut right into that, I'm going to cut all the crack out. So basically I will cut into that material that I built behind the crack. And the idea is to cut into clean material, so there is no crack left whatsoever. And once everything been cut out and cleaned out, I can simply re-weld, and I can deposit fresh material into this and then remove all excess that was left on behind. It is quite tedious, and it is a lot of work for some people, but the way I see it, when I started doing aluminum disc, I had almost 100 them a year to do, and I never had a single one of them ever come back to me for repair. So I presume that they're all working really well so far. I did see discs that I repaired before with the cracks in different places, but the welds actually have never failed so far. And I think it's one of the reasons is because of what I've been doing, and how it definitely works for me. It definitely works for you. You may have different method or so. So if you have different method or different way of doing this, just write it in the comment. I'll be curious to know, because yes, it takes quite a lot of time. However, it's easier if you do it right. Do it once, do it right. You don't have to look at it again. Plus, if customer comes back with a product that you repaired and it's broken, you know, in a couple of weeks time or a couple of months time, it just doesn't look very good for your business. So yeah, basically speaking, I'm cutting out that crack, and I'm cutting all material out so I can get right into clean metal, because as I mentioned before, high thermal conductivity of aluminum is actually what's stopping you from penetrating really deep. Even if you run it at very high amperage, what will happen is you will only penetrate so much, and depth of penetration is nothing compared to steel or stainless steel or wood, because aluminum is about 4 times more thermally conductive than normal steel, and when you trying to weld, it will just absorb heat like you wouldn't believe it. And that's pretty much one of the main reasons why heat sinks, in applications for electronics and so on, use aluminum quite a lot. So you see me using the cutting disc. I cut out big chunks of it, and now I'm just using the carbide bore to get rid of all rough surfaces, because I want to have as less crap floating around when I'm welding. It's unavoidable. You will see there will be still tons of stuff, but because I'm going to be running really hot, I'm not too worried about it, because I know that whatever is going to be in there, it will float up to the surface because I'm running really hot. So the point on this stage, what I'm want to do, I want to clean up all large pieces that are potentially could be oxidized or any sort of crap that may be in that material. As you can see, it's about depth of a finger, and I'm just making a little dry run to see if I'll be comfortable enough. It's quite difficult to weld and keep camera rolling, because normally I would have quite short tungstens, as you see, what you see at the moment, but for doing the camera, I will actually extend it a little bit, and trying to keep it rolling so you guys can see exactly what's going on in the welding puddle. If it's a brand new wheel, you may need to clean up a little bit of space for your earth, but in my case, right on the edge of a trim wheel, where wheel in the contact with the tire, there is actually bare strip of aluminum, so I'm trying to make a good contact on that. Bad earth, that's the biggest problem you'll have with the welding. And again, just start it off. It takes some heat, so you just wait till heat builds up a little bit, and right away you can see things floating in it. But as I mentioned before, it's not going to be a problem by any means, because the metal, the puddle is so liquid that whatever crap there is, it will just float up to the surface. And the aluminum is so reactive that the moment you scratch it, that scratch is already oxidized. It may be, you can argue about the thickness of the oxide layer, but that oxide layer will always present. You just cannot avoid it, simply because aluminum is such a reactive metal. So yeah, as you can see, running it really hot and trying to make sure that base melting before I introduce any wire. And again, because my angle is slightly less favorable than what I would like to use, I would prefer to have it more straight in, like 90 degrees. What you'll see is filler wire balls up a little bit every so often, and you see that you can hear a little pops in the arc, that the arc wanders around just a touch. So yeah, and then once you put a first run in, you can just carry on building up the whole thing and trying to bring material all the way up. The other thing I'm also interested, guys, if you still watching at this stage, because I can see many people actually just start to watch videos and then they drop off, so I presume they're not really interested in the subject. I just try to experiment with different color corrections, and this way you can see pretty much what you'd normally see in a welding glass, lots of green tint. So I'm wondering which way would you prefer it personally. Just write it in the comment or something, and we'll see how many people prefer one way or another, just so I know exactly what I need to do for future videos. But for some reason I think without a green tint it looks slightly different, and maybe you can see detail a little bit better because there is more contrast in the image. So I'll try to split screen just to give you a little idea how things look. Yeah, just a split screen, how things look, you know, if they're color corrected or not, and you can make more informed decision on that. But basically speaking, in this stage I'm just building up welds, and I'm not really worrying about the long time in between runs, simply because aluminium absorbs heat quite a lot. So I'm building up those welds to the height, and it may looks like there's a lot of material that gets deposited, especially when you see the final weld. It looks really broad, really wide, and many people, when they see it for the first time, they're worried whether it's gonna balance alright on the stand, for a balancing stand for wheels, and it always work without any problem. It's actually appears more strange than it appears bigger than what it is. And as you can see, there is still little floaters going on in the welding puddles, but they never cause any issue. At this stage you may wonder about the different amperage that I'm using and different settings and so on, and unfortunately I can't just give you a number that will work for you, simply because it depends on the manufacturer, whether it's original manufacturer alloys or whether it's been manufactured by third party, like one of those alloys you buy from a car store and so on. They vary in thickness quite a lot, and on aluminium it is the ambient temperature will affect it quite a lot as well. I know it doesn't seem like there is a lot, but it will actually make quite a big difference. In actual fact, it's good practice not to weld aluminium at 5 degrees Celsius or lower, simply because it will start to absorb heat too quickly, and with the rapid absorption of heat, what you have welding puddle that will solidify too quick. With solidification of welding puddle, what you have, the main of the issues is the gas hydrogen, the gas that causes brittleness in the welds. It actually very easily diluted in hot aluminium, and if welded puddle cools down too quick, then bubbles may not be able to float up the surface and get out, and therefore you'll have porosity in the welds. It's very common problem, a common reason for porosity, especially in aluminium. Again, simply because of such a high temperature conductivity of material that we work with. So, what else I wanted to mention about aluminium welding, since we are on the subject of aluminium welding, aluminium on the car wheels, on alloys, is you'll see many people talking about degrees and everything, and making everything super clean and so on, and all of these things add a little bit to your advantage, add a little bit to the benefit of having good welds. However, you also need to bear in mind that the welding process itself is actually quite defective, because what we have, we take normal metal, normal material or alloy, and we introduce heat, which changes the grain structure and some metallurgical properties of a material that we working with. So we already producing defective part. The only thing what we should be concerned about is whether the final welds actually produces the results that we need. And in normal environment in the labs, we get, every time you weld something, you do it before you get the job. You do a test, and that test proves that the method that you use is actually can result in acceptable results. So they're acceptable results for us. In this case, we don't really do the lab test simply because it will not going to be economically advantageous to do it. However, the acceptable results for us is safe operation of this wheel, and also that our welds do not fail. And because from experience I already know that I don't need to go in all of those little tiny details to achieve very little benefit in this case, because the force out of AC current that I'm using for welded aluminium is enough to produce results, as long as I follow procedure which I already have and running at those temperature settings or those amperage settings which I normally do. And as I mentioned, they will deviate to different alloys, because some of them will feel like you need more, some of them will feel like they need a little less. So going back on the subject of cleaning everything up, like degreasing and so on, it will produce effect without any doubt. However, for this particular job, it doesn't make any sense to go and spend time on doing these things, because the final result that you will get, you will achieve required strength and everything from those welds without doing these things, and therefore there is very little benefit from spending extra time and doing all of these things. Like with anything in engineering world, you've got to be smart and you've got to keep everything in a balance. You still got to make a really good clean up and the proper prop job. So what you'll see is the weld from a side, and I'm gonna try to put a filler wire, which is 3 mil or an eighth of an inch, and you can see it just pretty much the same height, maybe just a little bit more over that. But if you look from another point, you'll see that it looks actually quite wide. So we'll still need to weld a little bit on the top and make sure everything fills up all of those stops which we had when we run vertical welds. So I was running from vertical and turning over the edge, and once those beads put on, then we can start moving to the stage where we actually need to clean up the original welds which we made on the backing of on the internal of the wheel where a tire sits. So at this stage my material will actually going to be quite hot, because I put all of those welds in, and what I do, I use, as you can see, torch lights up and slows down, and all I'm using is just normal button on a TIG torch, and I'm using soft starts and soft stops for my welds. As I mentioned, remember that it looks like it's quite broad weld, but it's what you need to get in order to get full penetration on this in this situation. Otherwise you'll have a crack inside, and that wheel will never last. So all you need to do now is just flip it over another side. It's quite important, guys, when you have, especially if it's a brand new alloy, do not drag it or twist it, because there is lots of alloy dust and cut off pieces. As you can see, I'm just trying to put it as close as possible to the corner so I can work on it. And if you have dust or any other pieces of rubbish on those rugs, then your fresh alloy can get damaged. And in reality, the best wheels you can have for your car is actual steel rims, because if you bump something, if you bash it, it will just bend, it will not crack. But alloys can last you as well if it's a decent alloy. Especially there is quite a lot of custom made alloys for fancy cars, and obviously people spending more time and effort in making sure that those alloys actually function properly and one of the main reasons that you have the issue is because the sprockets and the wheel hub is positioned on the edge of an alloy wheel. If you would have it right in the middle, then the load would be spread evenly and it would last a lot longer. But unfortunately, on the mass production, manufacturers don't want to do that simply because they want fancy more appealing wheels, and that's one of the way of doing it. But obviously, you as a user have to pay the price. You see me using the 1mm cutting disc quite a lot, and I quite like it. I use it for for cleaning up, but you really got to be sensible about these things. Again, it's all of these things will come with experience. If you would have to buff out so much material, you would spend a lot of time with it, but because you're only cutting 1mm against 1mm of material, you can be fairly quick with what you're doing. I actually kept it at the normal pace, so I didn't speed up this part of the clip whatsoever, and as well as the welding, I didn't speed up any welding on that as well. But this should give you kind of indication of how much time it takes. Some people can slap the things a lot quicker, some people may take a little longer. As I mentioned before, this is something that works for me. And as you will see when you look in the cuts, or when you look at the final, when everything's gonna be cleaned up, there is no porosities in it. Normally, if you have porosity in aluminium, you'll see it really well, and there are no porosities that you can identify, so the welds are actually stands up fairly decent. And that goes back to what I was saying, we can easily have argon chambers and do whole prepping and everything in the argon chamber to make sure that the aluminium is not oxidizing and so on, because again, it's such a highly reactive metal. However, all of that makes no commercial point, and you're there to run your business, and obviously you can only run a business by being efficient and by providing product in a good quality, and the quality that you will get by following this method is definitely acceptable, because as I said, I haven't never actually had to repair my own wheel. So what's going on here, I'm just knocking out the big chunks of aluminium with a cutting disc, and I'm trying to get as much as I can to cut it off as much as I can, while not making sure I'm not going to dig into the metal and make any gouges or going too deep, because obviously that will have to result in the repair. And if you're going back and forth, cutting and repairing, cutting and repair, that's just a waste of time, which you don't really want to do. So this time I'm switching over to 3mm cutting disc, and I'm using the edge for buffing. Aluminium is very, very soft, so I can actually, again, because I have relatively thin edge, and I can get into that 90-degree corner where tire will be sitting, and I can use it just to buff it off as much as I need to. I'm gonna leave like a millimeter or a half a millimeter, so like between 20 to 40 thou. At this stage it actually pays to be a little bit more careful and not to go too hard on the thing. Just pay attention to where you're cutting and what you're taking off, and little by little it will get removed. Again, as you can see me, I'm just using the edge of a grinder. I'm not really using, I'm still using it as a cutting tool rather than buffing it, if it makes any sense, because I'm still running it on the edge, and this way I can go around those tricky lines where tire will be sitting, so where I need to have really good seal, and basically I just want to repeat the shape of the wheel as much as I can, so it matches the original part. And for that I just need to use to be quite precise, and that little edge just helps me doing exactly what I need to do. There are wheels on the market which are actually rated for aluminium and so on. I never had to use them because in this application it makes no sense, and in the applications when I do work for boats and for marine and so on, that I'm just using carbide tools, and that just defeats the purpose of buying specifically designed wheels for aluminum. And they're supposedly just being a little better for not clogging up with aluminum, but never really had major need for it. So by swapping to brand new flop disc, grade 40, if you go in with a finer grade, then disc will start clogging up, but grade 40 actually works really well on aluminum. And try not to push it too hard, just work your way in and out, and you can get really nice finish. The tire sits nicely against it. The disc that I'm using is brand new, so I can actually have a really good corner. I can finish off all of those little nooks and crannies where I need to get in whatever left from previous stages. And again, just paying attention exactly to what you're doing. You can see there is still a big lump that hasn't been addressed, and I'm not too worrying about that too much, simply because that is easy. That point is very easy for access, so I can actually knock it off very easy with the same flap disc just by pushing it at it. As I mentioned before, this is not the guide or the best way to do the wheel repair on alloy wheels. It is simply the way that works for me, and we've been using it for years, and as I said, it works every time. Haven't had the weld fail yet. And if you guys have different way of doing it, I would love to hear it, or just make a little comment, or point a link to your video, and I'll watch all comments, and I will definitely have a look and see how you do things as well. It's always good to learn new things. And if I just left this video rolling right till the end. If you want to see, you can always rewind it and see the right to the end. But for me, it's almost 1 o'clock at night, so I'm away to bed.